Hello, it's Mr. Schwanenkamp. We are doing the last section in this chapter today. We are doing 2.4, and we are talking about derivatives of exponential and logarithmic functions. This is a big thing. It's going to happen all the time. The good news is it's really easy. It's just a little bit of memorization. It relates to chain rule. For example, if you follow the AP curriculum, they actually do this before chain rule. But it makes more sense after, and you'll see why here pretty quickly. It's very closely related. It's two memorizations, and then once we get to that point, shouldn't be too bad. We'll practice and then review for our test and be good to go. Let's do it. All right, so two memorization ideas that we're going to work with today. The first one is e, okay? It's an exponential function. You know what an exponential function looks like. It looks like that, okay? Maybe a little bit better than that, but that's an exponential function. If you take the derivative of e to some power, where that u can be x or x squared or anything else, the derivative of e, is what you see. The derivative of e is what you see. So if it was e to the u, it's going to stay e to the u times the derivative of the exponent. So whatever's in our exponent, if it's u, we're going to multiply by the derivative of u. So the derivative of u would be like du over dx. Okay, so for example, here's what that means. If I had e to the x squared, the derivative of e to the x squared is what I see times the derivative of the exponent, so times 2x. That right there is the derivative of that. The derivative of e is what you see times the derivative of the exponent. Okay, you can see that there's a chain rule aspect that we are going to take the derivative of the baby, where the exponent is the baby. All right, let's do the next one. Natural log. If you have natural log of u, the derivative of natural log of is 1 over, and that's kind of where I leave it. The derivative of natural log is 1 over, okay? So if I took the derivative of natural log of u, it is 1 over 1 divided by whatever's inside the parentheses, so 1 over u, times the derivative of whatever's in the exponent or in the parentheses. So for example, if I had the natural log of x squared, the derivative of natural log of x squared is 1 over x squared, because the derivative of natural log is 1 over. We rewrite the baby, x squared, times the derivative of the baby would be 2x. So if I really put this together, it'd be 2x over x squared. So my answer would be 2 over x. That is what the derivative of natural log of x squared is. Derivative of e is what you see times the derivative of the exponent. Derivative of natural log is 1 over whatever's inside the parentheses times the derivative of that. All right, that's it. Let's do it. Derivative of y equals e cosine x. So the derivative of y, all right, y prime. The derivative of e is what you see. So we're going to rewrite it exactly the same. Times the derivative of the exponent. So the derivative of cosine x, hopefully you recognize that that is going to be negative sine x. So y prime is going to be, I'm just going to rewrite this. Boom. There's my answer. Done. Example 2, y double prime. So we're finding the second derivative. So in order to find the second derivative, I better find the first derivative to begin. The derivative of 2 goes away. The derivative of e is what you see times the derivative of the exponent. Well, what's the derivative of x? The derivative of x is just 1. I'm done. E to the x. Minus the derivative of x squared. Got to take the derivative of that as well. The derivative of x squared is 2x. Good, that's y prime, but that's not what I was looking for. I was looking for y double prime. So if I'm looking for y double prime, all right, cool, I'm going to take the derivative of this guy. The derivative of e is what you see times the derivative of the exponent. The derivative of negative 2x, negative 2. That's it. Okay, I could keep going. That just asked me to find y double prime. This is my answer. But just look, what if I was looking for the third derivative? Derivative of e is what you see. Derivative of negative 2 goes away. The fourth derivative would be the same thing, and so on and so on and so on. Derivative of e is kind of weird. It's a weird concept that the derivative of e to the x is e to the x. But look at the graph and kind of understand it. It'll make a little bit of sense. Okay, here's what I mean by that. Look at that graph right there. If you were to graph the derivative, you're looking at the slope. Well, the slope is steadily getting bigger and bigger and bigger. The slope is getting bigger. So if I graphed the slope, it would be the same graph and so on. dy over dx, we're finding the derivative of natural log of 2x minus 3. So we're finding y prime. What's the derivative of natural log? Well, derivative of natural log is 1 over. We're going to rewrite the baby times the derivative of whatever is inside the parentheses times the derivative of the baby. The derivative of the baby is 2. So y prime is going to be equal to 2 over 2x minus 3. Done. Example 4, natural log. Y prime, derivative of natural log is 1 over. Rewrite the baby. So I'm going to rewrite that. So I'm going to rewrite that as x to the 1/2 power times the derivative of the baby. So the derivative of the baby is going to be 1/2 x to the negative 1/2. That's my answer, but let's rewrite that in a little bit better form. So this is going to be y prime 1/2, so it's going to be 1 over 2. I've got an x to the 1/2 from this right here. I've got another x to the 1/2 on bottom because of that right there. So what's my answer going to be? 1 over 2x, because I'm multiplying these together. I add the exponent 1/2 plus 1/2 is x. Boom, 1 over 2x is my answer there. And we're just going to keep doing it. There's nothing hard about this. Okay, once you memorize it, it's pretty much the same thing every time. E to the negative 3x. That's all an exponent. That looks really ugly. The derivative of e is what you see times the derivative of the exponent. Ugh, what is that exponent? Well, it's negative 3x to the negative 1, right? In fact, I'm not even going to write it like this because that's ugly. Negative 3x to the negative 1. So I'm going to multiply by the derivative of the exponent. So I'm going to multiply by the negative 1, and then I'm going to subtract 1 from my exponent. Boom. There's my answer. So if I wanted to rewrite that, and you could do a whole lot of crazy stuff there with exponents moving up and down, but that's the main idea. Last one here on the front. Is that correct? Yep, last one here on the front. And we're going to find y prime. Oh, what is this thing? Well, this is parentheses 1/2 power. The natural log of 2x. A whole lot of different things going on there. You can see that this is a 2 chain that's happening. So we're going to take the derivative of the outside, 1/2, rewrite the inside. Cool. I took the derivative of the outside. Oh, I forgot to subtract 1 from my exponent, so now it's negative 1/2. Now I'm going to take the derivative of the inside. So what's the derivative of natural log? The derivative of natural log is 1 over the baby times the derivative of the baby. What's the derivative of 2x? It would be 2. You can see that this 2 and that 2 are going to cancel. There's a whole lot of craziness that are going to go on there, but I'm going to leave it like that. That's my answer. Okay, nothing too crazy. Flip to the back side. So this is not something I normally teach in AB, but I did see it pop up on the AB exam this year. So I wanted to at least expose it to you. Probably not anything you're even going to worry about until a couple days before the test. But other than that, just looking at it. E to the u. Technically, the derivative of e is what you see, including the natural log of e. Okay, the natural log of the base. Well, why don't I include that? Because what is the natural log of e? The natural log of e is 1, so it doesn't really matter. The derivative of e is what you see times the derivative of the exponent. So that's fine if it's just e. But what happens if it's this? So if we are using that same idea, the derivative of 7 to the 2x squared plus 3, the derivative of 7 to the 2x squared plus 3, the derivative of this exponential function is that same exponential function, but I need to multiply by the natural log of the base, so the natural log of 7 up there in front. Because this is an e, I include a 7 in there, natural log of 7, times the derivative of the exponent. So I'm still doing that part. The derivative of 2x squared, oh, that would be 4x. The derivative of 3 goes away. All right. So basically, the exact same thing as derivative of e. You just got to include a natural log of 7 because up here the natural log of e is 1. That's why we didn't include it. All right. So for example, if I were to take the derivative of this, 3 to the 2x, well, the derivative of an exponential is that exponential with the natural log of whatever my base is. So in this case, the natural log of 3. This looks super ugly. I'm going to rewrite that again. All right. So this derivative is rewriting the exponential, but I need to include the natural log of whatever my base is. And I also need to take the derivative of my exponent. So the derivative of my exponent is 2. So my answer would be 2 times natural log of 3 times 3 to the 2x. I have not seen that happen a whole lot, but it's basically the same thing. The derivative of the exponential is the exponential with the natural log of the base. It's a little bit funky. You can handle it. All right. Same thing would be true with natural log of u. So when we take the derivative of natural log of u, that one's easy. It's 1 over the baby times the derivative of the baby. It's this right here. Well, technically, it's 1 over the natural log of the base. Well, the base of a natural log, remember ln means log base e. So the derivative of natural log of e is just 1. Or I'm sorry, what is natural log of e is just 1, so we don't include that. So for example, if I were taking the log base 4 of 2x squared plus 4, it's 1 over the baby times the derivative of the baby. Oh, but I also need to include the natural log of whatever my base is. Okay, again, this is not the most important thing. Do not let this weigh you down. So if I were doing 8, I'm taking the derivative of a log. All right, cool. The derivative of log is 1 over the baby times the derivative of the baby. Oh, but wait, it wasn't natural log of e, so I need to include the natural log of 2 there on bottom. Hope that makes sense. It's kind of just memorization. I don't have a great explanation as to all the ins and outs of that, but that's the main idea. All right, let's try just a couple more of these because this is a quick video. These were problems that give students some hard time, so I'm just looking at it. Do I need product rule here for number 7? Hopefully you say no. And so a lot of students will try to do product rule here, but there's just 1x. What is e squared? Well, e squared is just a number. So if I said what was the derivative of 3x, the derivative of 3x would be 3. So what's the derivative of x times e squared? Well, e squared is just a number. So the derivative is just going to be e squared minus, what's the derivative of e? The derivative of e is what you see times the derivative of the exponent. Number 8, the derivative of e is what you see times the derivative of the exponent. The derivative of e is what you see times the derivative of the exponent. Boom. Those are just a couple more examples. 15, we're taking the derivative of natural log. All right, cool. The derivative of natural log is 1 over the baby times the derivative of the baby. We could put that back together. It'd be 2x over x squared, which is going to be 2 over x when I simplify that down. I think I did that one on the front side. Natural log of x squared. All right, I need chain rule. I got an inside, I got an outside. So I'm going to take the derivative of the outside, rewrite the baby, times the derivative of the baby. Well, what's the derivative of natural log? 1 over the baby times the derivative of the baby. Number 20. Do I need product rule on 20? Well, yeah, I do because I have two x's being multiplied. So let's do some product rule. So it's first times the derivative of the second. The derivative of natural log is 1 over x times the derivative of the baby, which would be 1. First times the derivative of the second plus second times the derivative of the first. Derivative of x would just be 1 minus the derivative of x. Well, what's the derivative of x? Would just be 1. Let's clean this up because we could put this together. X times 1 over x times 1. Oh, that's just 1. Plus the natural log of x minus 1. I got a plus 1. I got a minus 1. My answer is the natural log of x. Kind of strange getting all the way back to there. Just a matter of doing our work. Don't overthink it. Hope it helps. If not, ask me questions. Looking forward to it.